Good afternoon, everyone. We are back again. We are still doing our revision session on functions, and this is the continuation of the last video that I posted on YouTube. While we were recording last week, our battery ran off, so we couldn't finish our problem. But I think today we will finish it and do a lot of problems so that we can go into the exam knowing what to do and knowing what not to do. Without wasting any time, let's finish what we started. I believe in the last video we did 2 and 1, if I remember very well. Now we are doing 2 and 2. Let's read what 2 and 2 wants us to do. I believe we were still on it, but we didn't finish it. 2 and 2, it says determine the turning points of F and G. They want the turning point. They want the coordinates of here and the coordinates of here. If you don't mind, I will just put this aside so that we can work on here. We will start with F. We know that the x coordinate of the turning point of any parabola is given by this. Minus b over 2a. Now what is minus b? We got minus into minus 4 all over 2. What is our a? Our a is minus 1. It's minus 1 here. We get that it is positive 4 over negative 2. It will give us negative 2. Let me write another line here. We know that the x coordinate of the turning point is minus 2. Now we have to look for the y value where x is minus 2. We take minus 2 here and we plug into the original equation. We say that the y coordinate is into minus 2 squared minus 4 into minus 2 plus 5. If you put all of this in the calculator, I believe you will get 9. You will get 9, and we did this in the last video. And here we wrote those coordinates minus 2 and 9. I believe you can see over here. Now let's look for the turning points of G. We also do the same. We say the x coordinate of the turning point is given by opposite of b over 2a is given by minus into positive 7 over 2 into positive 1 is equals to minus 7 over 2. Now, what is the y value? What is the y value when x is negative 7 over 2? To find that, we plug in minus 7 over 2 into the original equation. We get minus 7 over 2 squared plus 7 into minus 7 over 2 minus 8 here. If you put that into the calculator, you will get minus 81 over 4. Our coordinate of the turning point is minus 7 over 2 and minus 81 over 4 here. I believe you can see there's too much light in here, but I hope you can see. And here we can write minus 7 over 2 minus 81 over 4 And we are done with 2.2. Let's move to 2.3. It says here, determine the domain of f and g. Remember that the domain, if you watched the first video that I posted on functions, you will remember that I said domain is all the possible x values of a function. If we look at f and g, we can see that if we plug in any x value, we will get a unique y value. In other words, we can say that 2.3, we can say that x is the element of real numbers, or can also say, or you can also say x is the element of all the numbers from negative infinity to positive infinity. And then, yeah, this domain is for both f and g. X can be any number. I hope you can understand. If you don't understand, you can put your comment in the comment section below so that I can explain even further. Let's move to 2.4. I believe 2.4 says determine the range of f and g. Now the range will differ for both f and g. Remember that the range is any possible y value of a function. Here we can see that, let's start with f. Let's write f here. Let's say f 2.4, y is the element of real numbers for f. Say f here, y is the element of real numbers, but y is less than or equals to 9. You can see here y can be anything below 9, and it can also be 9 and below. It can never be 9.1, it can never be 10, it can never go there. You see, it can never go there. And then when we are looking at g, we notice that g, let's write it here, we only look at the y values here. For g, we can say y is also the element of real numbers, but y is greater than or equals to minus 81 over 4. And you can see here x can be any number above minus 81 over 4. I believe that minus 81 over 4 as a decimal is minus 20.25. Y can be negative 20.25 and above, but can never be below that. It can never be like minus 21, cannot be minus 22, but can be minus 20 and above. That is the range here. Even if you look for the x value, if you look for the x value where y is negative 21, you will never get that x value there, because your graph here will never be minus 21. I believe that's clear. Or let's do it over here. Let's not just say, let's do it over here. We are looking for the x value where y is equals to minus 21 for g. Remember that the equation of g is here. We can say that x squared plus 7x minus 8 is equals to minus 21. We can say x squared plus 7x. When we bring this minus 21 to the other side becomes positive 1, positive 21, and we say minus 8 plus 21. It will give us I think 13. Yeah, I think 13, positive 13 here. Now let's look what's under the square root before we can solve the equation. We know that under the square root we have b squared minus 4ac. What is our b squared here? It's 7. We got 7 squared minus 4. What's our a is 1, our c value is 30. This is 49 minus 4 times 13, I believe is I believe it's 52. It will give you 49 minus 52, it will give you minus 3, and we cannot have a square root of a negative number. That's why we cannot find an x value where y is minus 21. That's all about the range, you know. And let's move on to the another question. 2.5, it says here, write down the equation of the axis of symmetry of f and g. Now the axis of symmetry of a parabola, they are very simple. Well, once you find the x coordinate of the turning point, you are sorted. And 2.5, let's answer 2.5 here. 2.5 for f, we can see that x is equals to 9 here. The axis of symmetry cuts the line of the axis of symmetry will cut this parabola here, so that we have an equal part in this side and also an equal part at this side. But for g, it will cut it right here at minus 7 over 2, so that we have equal part in this side and equal part at this side. So for g, we can say that x is equals to minus 7 over 2 is the equation of the axis of symmetry. And yeah, we move on. We don't want to waste time. We move on. Like I said, if you don't understand, you can post your comment in the comment section below, and I will try to explain that. Let's move to 2.6. 2.6 says or asks us to write down or determine the equation of the inverse functions of f and g in the form f inverse or f to the power negative 1 x and g to the power negative 1 x. This to the power negative 1, like I told you, doesn't mean 1 over g of x. It means the inverse of that function. Let's start with f here. 2.6. For f, if you recall, we said that f is equals to minus x squared plus, I believe it was, let me check again, it was, yes, minus 4x, sorry about that, minus 4x plus 5 here. And before we can swap the x and y values, let's put this into vertex form. We know that the a value is minus the, we know that a is equals to minus 1, a is equals to minus 1, p is equals to, we found it here to be minus 2, and then q here we found it to be 9, positive 9. We can put this into this equation here. Y is equals to a into x minus p squared plus q here. Now let's plug in everything that we know. We know that y is equals to, it's minus 1 here. You can put minus into x minus negative 2, it will give us positive 2. Because it's minus into minus 2, it will give us that positive 2 here. Squared plus 9 here. Now we can swap the x and y values to solve for y. We said that x is equals to minus into y plus 2 squared plus 9, and solving for y, let's move this term to the other side so that it becomes x minus 9 is equals to minus into y plus 2 squared. Let's divide both sides by negative 1 and negative 1. We get that minus x plus 9 is equals to y plus 2 squared here. We can also take the square root of both sides. Taking the square root, we find that, let's put this 9 in front, is 9 minus x is equals to, this will cancel, y plus 2. Taking this plus 2 to the other side, it will become y is equals to square root of 9 minus x minus 2. But they asked us to put this into f inverse of x is equals to 9 minus x minus 2, like that. Now let's do it for g. Do the same thing for g. Remember that g is equals to, g of x is equals to x squared, I believe it's plus 7x minus 8. Let's put it into vertex form. We know that a is equals to 1. We can put that x minus into minus 7 over 2. Remember our x coordinate was minus 7 over 2. Here it becomes plus 7 over 2 squared. And remember our y coordinate, where there is a turning point, is minus 81 over 4. We can say minus 81 over 4. Now we can swap the x and y variables, and then we solve for y like we did here. We say x is equals to, we can remove this one because it doesn't make much effect on our equation. X plus 2, sorry, it's supposed to be y here, not x, y, minus 81 over 4. We can put this minus 81 over 4 to the other side, it becomes x plus 81 over 4 is equals to y plus 7 over 2 squared, like this. And then let's solve for y. You can take the square root of both sides. This and this will cancel. We'll have the square root of x plus 81 over 4. I believe you can follow that. 7 over 2. When we bring this 7 over 2 to the other side, it becomes y is equals to square root of x plus 81 over 4, minus 7 over 2, but they said we must write it in terms of this here. Therefore, can put therefore g inverse of x is equals to square root of x plus 81 over 4 and minus 7 over 2, like that here. Yeah, I think this took a while, but we can understand what we did here. Before you can like swap x and y values, you put this into standard form so that your work can become easier and more understandable. And I hope you could, I hope you followed what I did here. Let's move on to another question. 2.7, for which values of x, yeah, many students are like, they have a problem when they come across these types of questions. Like, in my own opinion, I think they are the easiest questions in functions, but yeah, let's try to answer these questions. I believe by the end of this question you will have understand on how to tackle these questions. Let me write 2.7 here. 2.7.1, it says, for which values of x will f of x greater than 0? Here, f of x greater than 0. F of x is greater than 0 when x is between minus 5 and 1. We can see between minus 5 and 1, f of x is below this, is above, below, is above the line of x-axis here. So we can say that f of x is greater than 0 when x is between negative 5 and 1. We can write it in this way. Negative 5 is less than, is it less than or greater than? Yeah, less than. Less than x is less than 1 here. X is greater than minus 5, but x here is below 1. It means that x is between negative 5 and 1. And let's move on to another question. 2.7.2. 2.7.2. It asks us to find the values of x when f of x is less than or equals to 0. It's only less than or equals to 0 when x is equals to minus 5. When x is only less than 0 when x is is less than minus 5 here. Is less than minus 5. Less than or equals to minus 5. Or when x is greater than or equals to 1 here. Greater than or equals to 1. What these types of question mean is that which value of x will we put into this equation that we are given here, and it will give us a negative y value. It means for which values of x will we put that x value into this equation, and it will give us a number that is less than 0 or equals to 0. And we said that when we put any number that is less than minus 5, like minus 6 or minus 7, it will give us a negative y value. That's why it is decreasing at this side here. I believe you can understand Let's move to another question. For which values of x is g of x less than 0? We can see that g of x is less than the x-axis when x is equals to minus 8 or when x is equals to 1. I believe I did that correctly. For which value or greater not equals to greater than or equals to 0, we can see that where x has to be less than minus 8 and x has to be greater than 1 or greater than or equals to 1 for this equation to be, for this inequality to be true. We said that x for 2.7.3. If you want this this paper for practice, I can make a snap of it so that you can practice with it. And if you like you're stuck somewhere, you can watch the videos to see how you solve that problem. And yeah, let's move on here. We said that g of x is only positive when x is less than minus 8, when x is less than or equals to minus 8, or when x is greater than or equals to 1. Yeah, let's do 2.7.4. 2.7.4. For what am I thinking? For which values of x will g of x less than 0? We want the values where g of x lies below the x-axis. We can see it lies below the x-axis when x is between minus 8 and 1. We can write that here. Only when x, no, let me put minus 8 first. Minus 8 is less than x is less than 1, is between negative 8 and 1. If you put any number between negative 8 and 1, you will get a negative y value. Yeah, let's do the last question and conclude this video. I don't think the last question will do us any favor. It will be kind of, hard, but not too hard, but yeah, let's do it. For which values of k will f of x is equals to k have non-real roots? Now we are talking about the roots. When we are talking about the roots, remember about the delta there. We said that the delta is equals to b squared minus 4ac is the expression that is under the square root when we are using that quadratic formula. And then for roots to be non-real, delta, this delta here has to be less than 0. For roots, let me write non-real here. Non-real. For roots to be real, delta has to be greater than 0. Real roots. For roots to be equal, delta has to equals to 0. We have equal roots here. And since they asked us about f of x, for which values of k will f of x is equals to k? We said that f of x is minus x squared minus 4x plus 5 is equals to k. They said f of x is equals to k. We can take this k to the other side. We say as x squared minus 4x plus 5 minus k here, and is equals to 0. And then yeah, we can divide all sides by -1, -1, -1, -1, and -1, also -1. We get that x squared plus 4x minus 5 plus k is equals to 0 here. Now let's look at the delta here. Delta has to be less than 0, because they said for which values of k will f of x is equals to k have non-real roots. And yeah, let's solve the equation. So b squared minus 4ac is less than 0. This whole thing here, it's c, it's just c. Let's substitute in what we know. We know that b is 4, we square it, minus 4. A, we know that a is 1. C, we know that c is minus 5 plus k, but let's flip it. Let's flip it so that k comes first. We have k minus 5 is less than 0 here. Let's simplify. 4 squared is 16. Minus 4 times 1, it gives us minus 4. Minus 4 times k, it gives us minus 4k. Minus 4k. And then minus 4 times 1, it gives us minus 4. Minus 4 times minus 5, it gives us positive 20. Is less than 0 here. Let's simplify further. 16 plus 20, it gives us 36. Minus 4k is less than 0. We can move minus 4k to the other side, or to the other side, if you didn't hear me correctly, and it becomes positive 4. What am I doing? And if we divide both sides by 4, let's divide by 4. Divide by 4. This 4 will cancel, and we will get that 36 divided by 4. What's that? It's 9. Yeah, it's 9. 9. K is greater than 9 here, or you can say k is greater than 9. If k is greater than 9, then we will have the roots that are non-real. It means that delta here will be a negative value. And yeah, I never thought this will take so long, but we are done with we're done with question 2. We are moving to question number 3 now. I believe now you can answer any question pertaining parabolic functions or straight line functions, or the functions that we are about to do now. So stay tuned and watch the next video. I will see you in the next video. Bye.